Hello everybody, this is Tea Time Terror. I'm bringing you kind of an update video on a build that I put out on my channel a little while ago. The last video was an update to one of Scarhoof's smart smelting builds. I did like a minor change to it so that it wouldn't ping pong between different resources as it was smelting, and fixed a minor problem there in theory. But here I've actually taken his layout because I really like the layout. I like its tileability, and I like the general feel of it. And I have messed up the general feel of it by covering it in wires, but what can you do? But this now includes all four basic resources. This will smelt stone, bricks, steel, iron, and copper based on what you need the most. And a little additional feature I actually added to it was um, it'll only it'll commit 3/4 of the smelting of each of these tiles to whatever resource you have the least of. So in the network right now I have the lowest amount of copper, and there's ratios involved with that based on how much you would reasonably need of each of those. But right now I need copper the absolute most right now. So these three are going to produce copper. But what I need the second most is going to be stone bricks. So 1/4 of it is actually devoted to stone bricks, and this will kind of keep it from like I don't necessarily want all of them running copper if I'm super low on copper. Uh, it'll generally keep you at a more reasonable balance once you get it going. So how does this work? All of the coding here, or all of the combinators and all that, I did put within this as best I could, so that it remains tileable. I wanted everything to fit within the boundaries so that you could tile it without any issues, and each one will function on its own. Past that, I did actually do a kind of a small setup to show the actual coding that's stored within this. So what I did was, first off, it reads from the logistic network, of course. As you can see, we have 167-ish copper, almost 400 stone brick, 1,000 steel, and 1.9k iron. So what I did was, first, to get the ideal ratio that you want for things, I kind of just picked numbers based on what I felt at the time. And I base it off of what our base iron is at. So these are arithmetic combinators. Iron's going to stay the same. We're just going to keep that number and use that as kind of our base. I want half as much steel as iron, so I put this to ×2. So from here on out, it'll act as though we have twice as much steel as we do iron. And that'll effectively make the system think we want half as much steel produced as iron. I did 1/3 as much stone, so ×3 actually means we want 1/3 as much based on how this is coded. And then I wanted, for every 3 iron produced, I wanted 1.5 copper, or whatever my ratio there is. I figured it out at some point. Or I think it was 2 for every 3. Yeah, 2 for every 3 iron. So past that, and I just took that to a pull here to make it a little bit cleaner, but past that, it'll take those adjusted numbers, and that's what I'm going to refer to those as, is our adjusted numbers on how much we want of everything. And that's going to output that to these. These are decider combinators that are going to compare each incoming signal to each resource. And what that's actually going to do is it's going to output a number that ranks them on how much we have of each. And I had it output the raw resource instead of the final resource for this. So what this effectively does is it's going to say, well, what do we have? So we have a particularly low amount of copper in the system, in a particularly low amount of bricks, it looks like. And that should be... It's producing iron and copper right now, but yeah, that's because of the... basically, like, if we're at 1,000 steel, we want to be at 3,000 copper, stuff like that. Or 1,500. So it's just going to produce whatever we have the lowest of. And so what this does is it ranks each one on how many we have. So if something is a 3, it's the least satisfied thing, because it's going to compare it to the other 3 and say 3 things are greater than copper plates. So that's going to output a 3 to here. The second lowest resource is going to be steel. So that's going to output a 2 to here. Third lowest is going to be iron, and that's going to output a 1. And then stone doesn't output anything at all because we are good on stone. And then past this, I'm just going to take the largest number, or like whichever number is equal to 3, whichever number is the one that we need the most of effectively, is going to output to 3/4 of the smelters. And then whichever number outputs a 2 is the whichever resource that we need the second most of, and that's going to output to 1/4 of the smelters. And that's the basic setup here. It's not too complicated, or it took me a while to figure out just because I was overcomplicating it in my brain and trying to do some elaborate, like, comparative reasoning, and this works just fine. It could, in theory, use a few equal to conditions. It might run into an issue if all 4 of your resources happen to end up equal, but that if you're running an actual factory and not just producing into chests forever like this one is, because I don't have any actual consumption here, that should never be an issue. Because if you have things being requested in requester chests, things won't stay, like, you're never going to have all 4 resources be equal for more than 3 seconds. So, in addition, during those 3 seconds, they're probably smelting anyway. So that's the basic setup. It is still tileable, and I can show that off here. Just pop that down, and I don't think I have the resources in the system, but it's still tileable just like Scarhoof's, and that's pretty much the gist of it. The blueprint string will be down in the description. In addition, check out Scarhoof's channel if you're interested in seeing more of his builds. He makes some cool stuff, does some awesome looking factories. I found Scarhoof originally through Exterminator, so I wanted to shout him out as well. That's where I actually found his original build that looked like this. And that's basically the gist of it. Thank you very much for watching. Have a great night.